webinars hosted by Maine and IEEE Maine section. It's my pleasure to welcome you all. I would also like to thank IEEE China, India, Silicon Valley, Boston section for broadcasting this webinar. Today, we have a very hot and exciting topic, how to harness generative AI for education. And our guest is Professor Jon Ippolito. He's a professor of new media, co-director of Stillwater Lab, and director of the Digital Curation Graduate Program, University of Maine. And I am Julia Upton, IEEE Maine Section Chair. I will be moderating today's discussion. We expect this to be very interactive, so if you have any questions, don't wait until the end. Go ahead and type them into the Q&A, and Jon will be happy to answer them. Jon is a new media artist, writer, and curator whose work has been recognized with awards from the Thoma, Tiffany, Lenanon, and American Foundations, and he also curated at the Guggenheim Museum in New York. We're very excited to have you, Jon. The floor is yours.
All right. Thanks, everybody, for joining us. A lot to talk about. I'm afraid we have to do things via the Q&A today rather than a chat, but I am going to encourage you to interrupt me as I'm speaking with any clarifying questions, and I'm going to make several pauses throughout to bring the more expansive questions. And in today's talk, I've done a number of presentations before about nitty-gritty practical things that you can use in the classroom, and we will get to that. But I want to take advantage of the assembled expertise here to think about a broader perspective on generative AI and how it can be useful and when it's not useful. So really thinking through a framework for what is when AI in the classroom can be a blessing and when it can be a curse. So I am looking forward to your feedback on that, as well as questions about the nitty-gritty of the topic. It'll range across art and mathematics and education, so it's going to be kind of a wild ride. Let's get started. So I'm going to share my screen here. Bada boom. Okie dokie. You should see a kind of gray background that says Learning with AI as a logo. This is a project started by the New Media Program at the University of Maine, along with the Center for Innovation in Teaching and Learning, and UMaine AI, one of the sponsors of today's event, as well as a number of other departments. And the goal is to not hide from this technology and neither embrace it wholeheartedly, but to actually accept it and think critically through how we can use it in a classroom. That's me down there with the sort of my various socials and so on, and I'll bring that on later. So I want to start with a poll. I encourage you to, if you have a phone, you can scan the QR code. If you're at a browser, you can type menti.com, MENTI.com, and then just enter this code 7970 6765. And when you do, you should see something that looks very similar to the initial page I showed you with the Learn with AI logo. So voluntary, but would be very interested in your responses. And there's no right or wrong answer. I'm basically going to ask a poll at the beginning and then ask the poll again at the end and see if anybody changed their mind. So I see there's already 3 people who seem to have found the site and they're adding to it. Now we got up to 5. I'm going to go ahead and advance. What happens is if I advance the website on my end, it should advance on your browsers. Let me just sort of bring that over here. A moment. Okay, so this is what you should see when you go there. We've got about 9 people there now. I'm going to go forward, and now you should see the same instructions as before. Hopefully, most of you have got those by now. Again, you can scan the QR code and do it on your phone, or you can go to menti.com, 7970 6765. And then when we get there, let's see, I'll give just a couple more seconds for people who want to chime in and do this indirect way of voicing your opinion. All right, looks like we got about 36 people. Almost 40. All right. I'm going to assume most of you have logged in, so I'm going to go to the next slide. If you still need help, let me know. I can go back to that QR code or explain it again. Here's the poll. This is something that you should be able to contribute to in real time. The question is, evaluating this statement, it is technically feasible. That means it works. It'll actually work. And it's ethically responsible. So it's morally okay, as well as technically feasible, for students to use AI to blank. And summarizing research for a project, topic, organizing notes into an outline, writing a draft from an outline. These are all different tasks that you might do in a classroom. And the question is whether these are tasks that should be pursued. So you should be able to, I think, right now, go ahead and complete this poll. We should be able to see some results. And there we go. We're starting to see the kind of feedback in real time, people deciding how viable this is. So again, this is sort of you're checking to see whether it's both workable technically, like you could do it successfully with ChatGPT or the like, and is it the right thing to do? Is it a morally responsible thing for students to do this in the classroom? All right, interesting to see the horse race here with about 25 people reporting. So definitely organizing notes into an outline so far is winning the race, in the sense that people seem to think that's an acceptable task for generative AI like ChatGPT. And when I talk about generative AI, I'm thinking particularly about large language models, ChatGPT, Bard, Claude, and also text-to-image generators like DALL-E, Midjourney, and Stable Diffusion. So not really the specialized tools so much as the generic.
John, may I interject? There's a question related to the poll. A Socratic tutor. Please describe what this means.
Oh, great question. Yes. So a Socratic tutor is an interaction you have with someone. It can be a teacher, or in this case, a chatbot, in which they don't give you the answer. They lead you along with sort of leading questions to help you think through a topic. And it could be a topic that has no answer, like maybe a philosophical or an ethical question that has no right answer, or it could be actually a math problem, but instead of saying the answer is x equals 5, they're leading you through saying, like, consider the, transforming, the variables by subtracting a number from both sides. And then if you get that far, they say, okay, now think about, what to do when you're confronted with a quadratic equation. So it's sort of like you were a teacher in a classroom asking questions without giving the answer away. And that's a Socratic tutor. We can look at an example of ChatGPT doing that if people want to do that later. All right, so 51, that's a pretty good number. So organizing notes definitely is up there. Converting text into a chart is actually pretty high. I'm actually surprised that people realize that's technically possible. But Socratic tutor, not so much. Revising a draft is the lowest ranked one right now. But debugging code and writing code is actually, fairly up there. All right, that's the student. Let's see about the teacher. So I'm going to advance the poll 1. Now you got a set of questions about teaching. So as a professor, as a high school teacher, whatever your context, how do you feel about using AI as a teacher to, essentially create a lesson topic? You might do the research with ChatGPT. You might write the lesson plan itself with ChatGPT. What about a glossary? Those are handy to have to give out to students. What about flashcards, debugging code that students give you instead of figuring it out on your own or all on your own? Assessing rote homework, like, quizzes that are kind of multiple choice, or interpretive homework, more things like essays, art projects, that sort of thing. So we're getting some feedback here. Flashcards are in the lead, followed by a lesson glossary. Those are fairly rote kind of activities, so it's maybe not that surprising that those are getting more approval. Lesson plan, not so much. People who are teachers probably feel that their lesson plans are more territorial about that. It's something that they're either proud of or want to make sure they get it right. They don't seem to trust AI. And the worst one is excessive interpretive homework. That is where it's not just a matter of like you got the right answer or not, but there's some kind of, more subjective issues involved. That's pretty low, 2.3 out of 5. So less than 50% of people think that there's less than a 50% appropriateness of using that for the classroom. So that's pretty interesting results. I want to just see something quickly. I would say this is the students and this is the teachers. I don't know if there's any generalizable conclusion here, except that the students seem a little bit more even, like the tasks or don't have quite as variety of opinion about plus versus minus, whereas there's a pretty strong division here between things that are acceptable for teachers, like 4.1 for flashcards, and not acceptable or less acceptable, 2.3 for interpretive homework. So what we're going to do is go through I'm going to bring up some ideas and frameworks today, and then we'll go back and we'll do this this poll again, and we'll see if opinions change or not. So thank you for that. And thanks whoever asked the question about the Socratic tutor. Okay, so one of the big background questions here that I think speaks to the appropriate versus inappropriate use is whether AI is creative. And there are, in some of the tasks that people sort of dissed, like saying like, no, that's not appropriate for teachers or students, there was a kind of level of creativity or imagination or subjectiveness involved. For example, assessing interpretive homework. This is a huge debate right now in the AI community, as many of you know. Microsoft famously came out with a research paper describing sparks of general intelligence, as they put it. So this idea that like it seems to be developing an actual mind. And then, critics like Emily Bender, linguists from the University of Washington, say, no, these AIs are just stochastic parrots, in this very colorful term. They're just running probabilities on data that's been gathered from the internet, sucking down billions of web pages, assessing the probabilities that words will occur in a sequence based on that data set, and then sort of regurgitating versions of those back when you ask a prompt. And I am not going to go into the sort of basics of how these systems work. I'm going to assume that most of you know that a large language model is essentially a neural network applied to big data sets, primarily scraped from the web. But this question is still in contention between people who are quite expert in the fields, people who literally study linguistics and computational linguistics as their background, as well as AI researchers. And there's a lot of controversy there. So one of the things that I think is important to recognize is that there is a sort of mechanism behind the scenes that is generating the products that we see when we type things into ChatGPT or Midjourney or DALL-E or whatever. And understanding when that mechanism fails and how it fails can help us understand how it succeeds as well. So here's an example from the internet of someone trying ChatGPT and utterly failing. I'm trying to plan a 22-mile trail route in my state. This is a woman from Katy from New Mexico. She tried ChatGPT for route suggestions and it totally made stuff up. Once it made up a trail that doesn't exist to connect two other trails that do. So the picture that I've sort of suggested here is these green trails. Those are perfectly valid, actually existing trails. But the ones that are this orange sort of trail in the middle here is not. It's an invention of ChatGPT, and the trail does not exist. So some AI boosters like to call this hallucinating. I hate that term. We can talk about why. But I think a better term is fabricating, because it is essentially constructing something that isn't there. And the way that it did it in this particular example, I think, is instructive. It is essentially saying, well, if there's a trail that goes to here and a trail that goes to here, then there probably is a trail that connects them. Okay, that's kind of almost like a logical thing, we might say, but it is also at the same time a sort of an inference between two existing things. And that kind of mechanism of essentially taking the average of two things that are there is the way that these models work. Sometimes they're rather sophisticated in the kind of averaging they do mathematically, but it's essentially finding the middle ground between two things that are many other things that are already in the data set. So generative AI fabricates by averaging. And the problem is that the average of two facts isn't necessarily a fact. So we might give it a lot of data that's actually accurate. There are plenty of critiques about generative AI relying on biased data. And we know the internet is full of bias. But even if the internet, everything that it said there was true, the very mechanism of generative AI tends to generate falsehoods because of this averaging behavior. On the other hand, it's also true that generative AI creates new things by averaging. So I do believe that there is a level of creativity, at least novelty, inherent in these systems. And this could not exist without averaging. So what do I mean? Well, this picture on the left is actually a collage made by my father, who was an abstract expressionist, kind of a well-known artist in his time. And this is a piece that's made by ripping up pieces of newspaper and sticking them onto a wooden panel and painting around them and so forth. That was made in 1962. Here is a work more recent by an artist named George LaGrady. And boy, they look kind of similar. And you can say, well, he's just being a derivative artist. Well, no, actually, he made these with generative AI. So he essentially, I believe these were trained with a GAN, which is a slightly different system. It's generative adversarial network. But essentially, you feed it a lot of collages, and it produces new collages for you. They're not paper and glue on and paint on canvas. They are digital images, but the similarity is pretty striking. They're not just a cut and paste version of what was there before. You can't find a certain region of the canvas and say, well, that was stolen from this one other painting. No, they're new inventions, and they exist because the data set included the collages previously that inspired this. So this is a very strange and pretty remarkable to me result when I saw this, year and a half ago. These systems have predated ChatGPT by a year or more. And that idea that it could generate new images that were inspired by old images was pretty surprising to me. It does that also by a certain form of averaging, and these the different exact mechanisms can vary. Diffusion models are different from GANs and so forth, but essentially there is a kind of reckoning with what was there and finding something in the middle. So we might ask ourselves how this is possible. Like, if you have an average, right? Average of 3 and 7, is this the number 5? There's nothing surprising or interesting about that. Average is a synonym for us to mean boring and every day. So how could novelty come out of averaging? Why would we not know about the number 5 if we already knew about the numbers 3 and 7? But this is sort of a mindset carried over from elementary school math, where we're used to thinking about a number line and averaging in a sort of linear dimension. What happens if we add multiple dimensions? Well, then we might be averaging vectors. And as some of you know, the large language models essentially turn the data set into a big vector space, where the proximity of vectors is determined by the correlations between the words or the images or whatever the data is set from in the actual original sphere. So if two words are similar or closely related in the web, they tend to be correlated. Then the vectors that correspond to those, which are just arrays of billions of parameters with different probabilities in them, those two vectors will be close to each other in this abstract space that is represented by the large language model. So the neat thing is that even though our sort of intuition from averaging in middle school math is that averages are well known, in fact, in a high dimensional space, you might end up with a point that is the sort of sum of an average of the vectors that are being used or triggered by the prompt that has never been seen before. And that's because these very high multi-dimensional spaces span just this vast sort of room, including mostly experiences we have not had. So yeah, you throw billions of web pages in there, but there are trillions, quadrillions, it's this sort of unlimited number of potential web pages that could be generated as a result. And that's a very different attitude toward averaging. But it does raise some interesting questions. Like, okay, so if there is this kind of latency, this kind of in-betweenness where you could find something new, where the large language model or whatever the generative AI is could generate something new, then is it possible that they can just kind of think through and create completely new concepts, images, art, music that we've never seen before? And that it's not just some kind of middle ground, but actually something outside of that, something outside of sort of pressing the boundaries, if you will, of the art or the music or the text that we've already generated as humans. And that's a really interesting question, because when you do vector, kind of algebra, you don't necessarily always get something in the space that you were at as sort of in the initial configuration. Let me give you an example. I think it would be clear. So it's possible in these vector spaces to think about vectors that are parallel, right? So there is an analogy between man and king. And you might ask yourself, well, if I took those two points in my vector space, the point corresponding to the word man and the point corresponding to the word thing, and I drew a vector that is the difference between them, that is a vector that points from one to the other, okay? That's sort of a subtraction, essentially, in math. Then I have a direction. It's not just a point in space, it's actually a direction in space. Well, what if I take the word woman and I apply that same vector to it? I add that direction to it. What will I end up with? Well, you can predict what it is as a human because you've done a lot of thinking about analogies and you know something about culture. Can large language models do that? The answer is yes. ChatGPT will answer that the equivalent of a king for a man is for a woman a queen. So it's essentially followed through on a metaphor or an analogy. And that's pretty exciting because much of the conversation about large language models has focused on the fact of things being close to each other, things being correlated. And because they appear together, then they are related. So linguists call that metonymy. And it is it's great. It's often helpful to see things correlated, but it's not the same as a metaphor. Metonymy and metaphor are sort of two different scales of thinking through things. And a metaphor is more of a leap, more of a conceptual simile that you see something, you say, this is a pattern. And even though it's not appearing together, I can see the same pattern in different places. So, an example would be spirals. The word spiral can be seen by humans in many different contexts. There's a spiral galaxy, there's a spiral, shell, a nautilus is a spiral. And these are very different scales and contexts, but we see them and we see the pattern. So that kind of pattern recognition is something that if it can happen in that expansive way is kind of exciting. And so the question is, can ChatGPT do this? And could kind of, directing the thinking in new lines and new directions, push beyond the assembled data set into new ideas that haven't appeared before, into new art, new music, new literature that has not appeared before? Because it's very good at this kind of averaging hybrid thing. As an example, you can ask it to do a haiku of the Magna Carta, or you can ask it to write a limerick in the style of a pirate's voice, explains Einstein's general theory of relativity, and it will do it. It'll do an amazing job because those are sort of middle points between two known kind of contributions to the data set, and that middle point has never been explored, but it is essentially sort of the average of those. But what about when we push it to something that's even further, something like dog? Like, if man is to king and woman is to queen, as dog is to what? That's something that I think I'm not even sure what the answer might be. Maybe it's an alpha male or female. I really don't know, but it'd be curious to see if ChatGPT could handle that. So I did a little test this morning to see what would happen. And let me see if I can bring that up. Yeah, okay. So here is me doing a test of ChatGPT, asking it to do analogies. And I could do this live, but it's faster if I just sort of pre-record it. So here we go. So I've speeded up my typing because my typing's slow, but I gave it the normal time. Complete the following analogy. A man is to a king as a woman is to what? Now, it actually took a long time. I kind of accelerated the time there, but it took a long time to give me the answer, which was kind of interesting. I'm not sure it was network lag, but I feel like it did sort of like have to think about it in a way. A man is to a king as a woman is to a queen. Hooray. I would say that's, most of us would agree that's probably the right answer. Here's another analogy. Complete the following. Okay, now I'm going to push it. Man is to a king as a dog is to what? Again, it took some time. And then it said, man is to a king as a dog is to a loyal companion or faithful friend. Well, I don't know about you, but I'm kind of disappointed with that answer. To me, that is really looking to the way dogs are described relative to men. So it's sort of falling back to metonymy, that is things that are close to each other correlated, as opposed to really stretching our thinking, stretching to come up with something that is really outside of the boundaries of this kind of space spanned by the existing knowledge. So, I suppose in some way, that could be considered an analogy because it's like a king is a kind of human and a friend is like a human. But I think that's a total fail, in my opinion. Let's go a little further. A man is to a king as a donut is to what? Right. So I'm really pushing it to try to be creative. And this time it answers pretty quickly. Man is to a king as a donut is to a dessert or treat. Okay. Again, sorry, you just dropped the ball there, ChatGPT. That is not an analogy that I would consider successful. So, I think there is the theoretically the possibility of pushing beyond the existing space spanned by the knowledge we feed into it. But in practice, it fails so far, in my experience. Some of you may have had experiences where you can get it to do more creative stuff than that. But to me, this is more evidence that thinking about averaging and finding new places in the latent space is really the right way to think about ChatGPT and the like. So what do we do with that? Well, I think part of the background here that we also need to understand is probability. And probability is a concept that a lot of people find confusing. A lot of the things we think of as intuitive aren't really intuitive when it comes to probability. But maybe I'll pause there for a moment and see if there are questions that have come up with so far about what I've said so far.
Yes, there are a couple of questions about vector spaces. First one, it sounds like John is saying the output space of this generative AI are convex. Is that right? Do we know anything about the topology of the output space?
That's a great question, and I don't know the answer. So I think that's something for people who are more deep into the mathematical research of particular models to answer. My opinion so far, based on my testing, is yes, but I am not. This is not my entire research focus. So I would defer to others who might have done studies to prove or disprove that.
Right. Well, as a mathematician, I can chime in and say that we don't know. There has not been any extensive research done into the topology of the output space there. And actually, it will also vary depending on what kind of AI model we're talking about. So, and
that's great, Julia. Thank you for. It's great to have someone expert here holding my hand as we talk through these things.
And one more question. In the vector space 3D average slide, you noted a new point that was shown between existing vector points, while noting that it is possible to generate points outside the existing. Is this reference to something like latent space interpolation or something else?
It's exactly latent space. And I'll actually show a little bit more diagram to kind of explain that a little bit more coming up. But yeah, that's the term that I think is actually a pretty good term to describe points that are spanned by the existing data set, but have not yet been surfaced until a prompt kind of brings those out. Because remember, these are probabilistic engines. If they always ran based on what the closest correlation was, then if you ever said, the boy crossed the blank, then street would always come up highest because street would be the highest, number in the list of probabilities that the vector consists of. But instead, because it's a stochastic program, it's going to kind of search through and give you some numbers, like essentially rolling a die every time you ask that question. So it might be sometimes the boy crossed the field, or the boy crossed the land or the threshold or the door, whatever. And every once in a while you get something absolutely weird, like the boy crossed the sea, I guess that's not that weird, but the boy crossed the elephant might be a little more weird. But again, it's probabilistic. So we're because the number of parameters is so ridiculously high, the chances of creating exactly the same text over and over is very unlikely. And the chances of creating something that has not been actually written by a human or maybe even thought of, conceived when it comes to the images is also pretty high. It's one of the reasons I don't believe detectors will ever work. But yeah, latent space is the right term.
Thank you, John. That's all. Okay, there's maybe one more. Yes. Could you provide an example of a response that would be considered going outside the boundary that averaging is constrained to remain inside?
Yeah, so I tried to show that in the last example. Like, there's plenty of correlations between, man and king and woman and queen that you'd find in the literature if you just went out and looked at stories or books or web pages. But there wouldn't really be one between, king and dog, or that's not a very common correlation. So I was really trying to push it to see if it could get outside of that, the space that is sort of the averaging, if in that sort of generic sense of the word averaging. And it didn't succeed for me. Maybe someone else can manage to get it to do it, but so far, I'm reading this so it is that is actually a constraint.
All right. One more question. Is your interpretation of the man to king pattern performance issue that the underlying cliche is inherently limiting, or is it something else?
Oh, that's a great question. So, the word cliche is a tricky word to use. I do find that its writing is cliched. I find that the images it creates are also cliched. But I think that sometimes if you mash two cliches together, you get something that isn't a cliche. And that's where I think it can be the most creative, right? So again, one of the first times I ever used this in class, I said, okay, this is going to kill the book report, the kind of middle school, high school essay. You're not going to be able to do that anymore because you can just write in a prompt and generate a 5-paragraph essay in 30 seconds. And so I said, okay, students, what's a common book you read in, high school or whatever? And they were like, Lord of the Flies. So, okay, so let's write a book report on Lord of the Flies. And you can specify the level that it should be written at. Should we write it at a high school sophomore level or a college senior level? Or, and someone said, kindergarten. And I was like, okay, it's kind of a rough book for kindergarten, but let's try it. And it did an amazing job. It was like, the boy went to the island. A bad man took his food. The boy was sad. And I was like, wow, that's an amazingly creative thing. Was it entirely new? No, it was like a mashup of two existing things, a kindergarten story and this, young adult fiction story. So that's what I think it's actually good at. So again, yes, I think it works with cliches, but sometimes the right kind of mix of cliches can actually be creative.
There's nothing new under the sun. Okay, that's all the questions for now.
All right, cool. Let's go on and talk a little bit more about those probabilities, because I think that understanding them can help us see how we can actually make decisions about what is a good use of AI versus not so good. So I'm going to go back to share my screen again. Boom. Okay, you should see this meme about people arguing about, the 50% chance of success for the surgery. So again, people have a lot of misconceptions about probability. And one of the major ones, I think, is what I call opportunistic solutions. And some of you may have heard of these examples before, some of you may not. Chance of 2 people out of 23 in a room. You get 23 people in a room, the chances are higher than 50% to have the same birthday. That's a shocker, right? When you first see this, you'll be like, that can't be right? It must be, 23 out of 365 or something like that. The misunderstanding when you do say something like, oh, well, the chances are, that it's with 23 people, then 2 of them having the same birthday, that would have to be out of 365. The thing that leads you astray mathematically is when you try to think about what's the chance of 2 people having the same birthday. A much better approach to the problem is to ask yourself, what are the chances that 2 people don't have the same birthday? And then you end up with a sort of additive factorial thing. I won't go into math for reasons of time, but it turns out to be pretty unlikely that 2 people, that for all possible pairings of people out of 23, none of them have the same birthday. Once you get past 23, the chances are quite likely. And it's a really fun exercise to do in class because students are always shocked that 2 of them happen to have the same birthday if your class is big enough. An even more striking example of this, some of you may have heard of, is the chance of your next breath, right? Breathe in, including 1 molecule from Caesar's dying breath. Julius Caesar stabbed on the Senate floor. One of those molecules that he breathed is 98%. Like, how is that even possible? Well, it's possible because, again, the idea is not ask what are the chances that, a molecule got in there. Ask what the chances a molecule didn't. You end up with a mathematical formula that's sort of like 100% minus what that chance is. And it turns out to be staggeringly high. Now, I don't have time to explain the math, but think of it this way. There's your lungs, which includes a huge number of molecules. A liter has, I don't know, like 25 centillion molecules or something. It's just huge number. And then there's the atmosphere of the Earth. And the atmosphere of the Earth, assuming it gets, sort of normally distributed and the atoms don't disappear and come back and forth. There's a little bit of hand waving there, but basically the atmosphere of the Earth has a certain number of lungfuls in it, right? Well, in a qualitative sense, the number of, well, I guess a quantitative sense too, the number of molecules in a lungful is way, way, way higher than the number of lungfuls in an atmosphere. And if you do that out in terms of probability, the chance that one of those molecules is going to creep into your next lungful is extremely, extremely high. And I call these kind of problems and the solutions that answer them opportunistic. The idea is that all you need is one thing to succeed, and it works. And they're very strange problems. When you look at them, you say, well, I can't possibly write. But when you look at the mathematics, you see, oh, well, I guess in the end, it makes sense because I'm just looking for an opportunity. And so I call this distinction between problems that are like that and problems that aren't, opportunity versus prescription. So if you're trying to crack a safe, and let's be honest, who hasn't, you're just trying to find the right combination. And you might try like 6 or 7 or 100 or 5,000 combinations, right? You might be a hacker who is trying to brute force a password, trying millions of combinations. All you need is one of those to work. If you get a bunch of errors, who cares? You just go on to the next one until it works. That's an opportunistic task. That's an opportunistic sort of solution when you do finally find the one that works. On the other hand, if you're trying to disarm a bomb, and who hasn't tried that, you want to make sure you clip the right wire. If you clip the red wire and it's supposed to be the blue wire, that's not a good thing. So I would call that a prescriptive task. You really got to get it right. And it's no good to have a false negative or a false positive or just make a mistake. Another example you might have from the military. So, if you're laying siege to a fortress, and, who hasn't done that, all you need is one way in. As soon as you get one break in the wall, the troops flood in and, basically that's it. The siege is over. But if you're the defender and you have to sort of, guard every rampart of the castle, you have to make sure there's no holes anywhere. It's not an opportunistic problem. It's a prescriptive problem. You need to make sure everything is working properly. So in that case, that mindset, this framework I'm suggesting between opportunism and prescription might be a way of thinking about generative AI. And let's see why. When you start with the text that you download from Common Crawl or whatever, for ChatGPT, say, it's just a whole bunch of kind of vectors, each of which corresponds to a word, and they're sort of in this jumble with no organization to them. So if I look at words like pet and velociraptor and dachshund, they're sort of equidistant. And then the process of training sort of says, okay, let's look at the correlations in all the web pages we scraped and see which words are close to each other. And when you're done, you've changed all of the vectors. So now the probabilities of, one word being associated with another word are spaced out in a way that reflects the semantic reality of the internet. So pet and dachshund are going to be a lot closer than pet and velociraptor, because you're not going to see pet and velociraptor very often in the same web page. But here's what you can do. You can also associate images with those texts, because the web is full of images captions. And HTML tags attributes called alt tags, which sort of specify for people who have vision disabilities and so forth what's in the tag. So that also makes now an association between images and words. So that the image over here on the left is more likely to be associated with pet and dachshund, and the image over here on the right is going to be associated with velociraptor. So far, we've managed to create this space, this vector space, where we've got the things that we found online have a kind of logical sort of separation from each other. But what we can do is to say, give me a girl with a pet velociraptor. This is typing a prompt into, in this case, Stable Diffusion, and getting result. And what you see is that even though this image never appeared before, it is in some ways a natural outcome of averaging the image for a pet dachshund and an image for a velociraptor. And I'm leaving out the specifics of how the image is created, but essentially that's the underlying logic. That's the latent space, what I'm calling the latent average between existing norms. And I've given a pretty simple example where there are only 2 points, but now you imagine there's millions of points, and you're basically finding that kind of average between them. I think that's a good way of thinking about how these systems are working, and also helps us understand what's a successful application and what's an inappropriate application. So, there's a trade-off here between creativity and trust. The more creative something is, the more it's likely to kind of explore parts of the space we haven't assessed yet, we haven't determined. And sometimes the average of 2 facts is a fact, but sometimes the average of 2 facts isn't. There are no girls with pet velociraptors outside of Jurassic Park movies. So to the extent that we train a system really carefully, and so far, to my knowledge, this has only been done with specific situations like vision, machine vision, and other classification systems, and they're really, really right most of the time. Well, okay, that's a trust system. I could maybe trust that more, but it's less likely to create something that's creative to generate real true novelty. Whereas the more likely a system is to create new true novelty, the less likely we should trust it, because it's being creative. It's almost like a truism there. So we might divide the tasks that people are talking about applying AI to opportunistic tasks for which creativity and brainstorming and exploring that latent space is fine, versus prescriptive tasks for which, no, we really want to get it right. So as an example, radiology is one of the professions that is most under threat by generative AI right now, or AI in general, I would say, because AI turns out to be really good at reading X-rays. And to me, that's a fundamentally opportunistic challenge, because AI might find like 3 things in an X-ray they're worth looking at. Well, maybe 2 are just anomalies or just random stuff that happened fine. But if the 3rd one is really a tumor, you want to know. So the idea of giving you lots of extra information is not a problem. Apart from the dismay that a patient might have, and someone saying like, well, we found something that might be a tumor, we're going to look into it. It's a net benefit to have that opportunism of just like looking for solutions, even if not worrying about if any of them happen to be perfect. On the other hand, something like prescribing, heart medicine, you get that wrong, the patient's dead. And there are some contexts in pharmacy that have opportunistic challenges, but something like, prescribing this specific dosage of a heart medicine is probably something you want to get nailed down, right? You don't want to be like, let's give this a whirl. No, you want to be like, okay, pretty sure this is going to work. I'm not going to rely on generative AI for that. I would not want my doctor relying on generative AI for that. If we think about applying that to education, so I've kind of done a big tour around some issues in probability and how the language models work, but now let's go back to education. How will we actually make decisions based on this framework in the classroom? Well, Learn with AI has a compendium at learnwithai.org of strategies that you can apply in the classroom and decide what works and what doesn't. And it's a crowdsourced system. I'm happy to share, there's a forum that's in beta that you can submit to, and it'll appear in the system and all. You can filter by tags and narrow right down to, I want a prompt that has to do with history and writing an essay, or I want an article that describes, the issues of accuracy in healthcare context. Like it's got an interface that lets you zoom in pretty quickly. But one of the things it can do is to point out particular strategies and have you see them in action. So here's a few that I picked out for today, and I thought maybe some people would like to maybe not vote, but ask to see some of them in action. And they're just little screencasts of a few seconds each of using ChatGPT in this case for each of them. So if you have anything in the Q&A that wants to try out some of these, I'm happy to demo
them. There is a question about opportunity versus prescription.
Okay, we can do that.
Is there an approachable boundary case between opportunity versus prescription?
I haven't thought that through. It's a really good question, and I encourage people to think about what that might be. But some of these examples in the demos here might actually show it. Well, let's look at one. Someone asked about a Socratic tutor. I think that a Socratic tutor is actually a really good example of an opportunistic solution. So here's me talking to ChatGPT as a Socratic tutor. Let me bring it up this way. I think it'll be easier. Where is my Socratic tutor? Here we go. Okay. So I was like, okay, let's see if I can get, let's see if I can have an argument essentially with ChatGPT about being a Socratic tutor. Again, a Socratic tutor doesn't know the answer, it doesn't tell you the answer, it makes you think about something that you're working on. In this case, it's not a math problem, it's a particular example. My prompt is acting as a Socratic tutor, test my logic by asking questions. And then, it basically says, yes, I understand. And then I start with a provocative claim, gene editing is unethical. And it says, what specific aspect of gene editing do you believe makes it inherently unethical? So it's not challenging me or saying I'm wrong. It's just saying like, what specifically are you thinking about? And so I'm like, okay, it's the other way. Modifying the DNA of an unborn embryo could result in designer babies that, and I'm kind of thinking as I'm typing, create unfairness or an overemphasis on, traits a person is born with rather than qualities they achieve on their own. So I'm like, okay, I won that argument. It's like, is it possible that gene editing could also be used to prevent serious genetic diseases and promote health quality rather than just designing designer babies? And I'm like, all right, I kind of predicted that was coming. So I'm gonna respond and be like, okay, it's possible, but the line between genetic interventions for health versus cosmetic or eugenic reasons is too blurry. So, okay, I won that argument. Could establishing ethical guidelines and regulations help to draw a clearer line? I'm like, whoa, okay, all right, let me think about that. So I'm saying like, it's possible, but, some countries might pass those laws, other countries don't, that would amplify the inequalities. So I'm like, okay, got me. Would the potential benefits of eradicating genetic diseases and promoting health outweigh the risks of increased inequality if international cooperation and oversight were implemented to minimize those risks? So I'm like, wow, it really is forcing me to think outside of my expectations and consider things I hadn't thought of. To me, that's a pretty good example of what I would call an opportunistic solution. That is, helping a student think through, you know, in this case, an ethical question, but it could be even just knowledge questions or, you know, other kind of political issues and so forth, with ChatGPT.
John, there was a request to demo, analyze reports, and visualize data.
Oh, that's a good one. Okay, let's look at that one. Let's see. I guess this is the easiest way to do it. So I wanted to see how far you could get multimodally. That's going from one thing to another. So I made this sort of Star Trek like. Hold on. Let's just bring. I think it's faster if I bring it up this other way. Boom. Planetary survey. Okay. So I made this sort of Star Trek-like experience, and I didn't want to confuse. I didn't want it to think that it was Star Trek because I didn't want it to rely on what was already out there. So I invented new aliens or whatever. But basically, I wanted to summarize source texts, and these source texts are planetary surveys that have been done by, you know, people in the field, and I gave them the information from 3 different planets and the kind of species and people who were there. And it gave this summary, which we know ChatGPT is very good at giving summaries. I did ask it to then convert the summary to structured data. So I'm seeing, can it take information like that and put it, in this case, in the form of JSON, which is a common sort of code aspect, and it did. And I gave it some, you know, hand-holding for that. And I said, okay, can you visualize these data in a chart? This was actually before code interpreter, so this is like not even as good a version of ChatGPT, but as you can see, it's generating all this code for me. That's supposed to make a chart using a JavaScript framework called D3. So I loaded the code and I tried it out, and it's like not very good, but it did make a chart, didn't break. So I was like, okay, I want you to change the columns, and I want you to make sure that, you know, this is this way, and that rewrites the code. And when I tested this one out, it was better. Finally had a comparison of the 3 different civilizations based on the criteria I asked for. And then I said, well, let's have a color for each because that'll make it easier. And so, you know, it gave me the new code with the color. And then it kind of stopped partway through. So sometimes you have to ask it again to kind of regenerate after a certain point. So it got kind of stuck and I had to prompt it to go again. The very few prompts work the first time. You really have to kind of have a conversation with the chatbot. That's a good reason they're called chatbots. And then I followed the instructions, and boom, I got a nice chart in the end. And then I asked it, okay, based on this chart, oh yeah, I asked it to change labels, you know, add some stuff, whatever, very minor changes, so you could read the labels on the chart. And then I said, I want you to draw a conclusion. Can you draw a conclusion from the chart? And again, giving it a role. You're the captain of the Star Navy. You have to decide which sort of species to collaborate with, to invite to join your federation, essentially. And it basically gave the information that I kind of predicted, that this one civilization had the best scores and this and that, and to say that the ones we should ally with, but it also gave disadvantages of each. And this was a pretty convincing sort of conclusion based on the information I gave. And then I tried to see what would happen if it just had the JSON. Could it draw a conclusion from that? So excluding all the previous information it had. And it basically chose what's sort of the equivalent of the Klingons, which surprised me, the warlike race. But it gave a decent reasoning for doing that. And then I said, do it again. Right. So I was like seeing if probabilistically it would change. And the second time it in fact chose a different group, the ones that were more like the sort of logical Vulcans, which was not a huge surprise. So again, these are probabilistic. And if you ask it the same question more than once, you might get a different answer. That speaks again to the opportunity versus prescriptive model. If you can't be sure it's going to give you the most probable answer, then it's better for opportunistic problems. I did also ask it, a friend suggested writing a persuasive essay to tell letter to tell the civilization that I chose to join us and why we should join together. It loves the term esteemed leaders of the Feistian civilization. I love the sort of formality of it. And then I also asked it to write a conciliatory letter to the civilizations that didn't get chosen that was very tactful and diplomatic. And it did a pretty good job at that too. So those are sort of examples of multimodal conversations with ChatGPT, and that I think was an example of something where you could see that knowing the difference between an opportunistic problem and a prescriptive problem might help you choose which is best and which isn't.
All right. So we have a couple of questions. How does complexity factor into prescriptive versus opportunistic?
Oh, that's a really good question. Actually, while we're doing that, what I'd love for people to do is go back. I am going to reset the results of our poll, and I'd love for people to go and try, if I can get this to work, reset for entire presentation. I'd like to see people do the poll again. And so I'm going to go temporarily back to that slide where you can, or you can just even, I think, reload the page and it will show you the sort of student piece. Is it responsible technically? I just want to see if people feel differently than they did at the very beginning. So you can go ahead and vote on that. So the question was complexity and whether the complexity of the problem is a factor in determining its opportunistic versus prescriptive nature. I would say maybe not. I haven't, it's a great question. I need to think about it more. But I'm surprised at how many super complex problems have opportunistic solutions, and how many simple problems may have a prescriptive solution. But it might also be culturally dependent, because if you have a lot of different sort of evidence that you should do something, then you might think that's simple. But for a culture that didn't have that evidence or came from a different background, they might not think that that was simple.
One more question. I'm still wondering how one could test the veracity of the statement, AI cannot go outside the averaging box. If the AI had responded, man is to king as dog is to owner, would that still be considered inside the averaging box? Or would it be considered going outside the box because it succeeded at finding an analogy which was felt to have no inside the box answer?
Wow, that's a great answer to the analogy, actually. A human came up with a really good one. Thank you for that. It's a good question and an important problem. I'm going to actually jump to the next slide, assuming people have finished that one so that they can answer the teacher poll too. I think that this might be a little challenging in the context of familiar statements and words. But I think most of us have seen examples of brilliance from humans. So, for example, when a scientific theory comes out that really blows the lid off the previous understanding of the universe, or when an artist creates something that is really unusual and shocking and sometimes not understood for years until afterward, we as humans are capable of recognizing that kind of creativity. And there is a creativity that comes through remix. There's no question that hybridizing things can be a creative act. But I think that the idea that people are won't recognize novelty when they see it isn't true. I think as humans, maybe there is a subjectivity involved, and I'm guessing you could probably create a more objective test. But I think that that's one of the things that really drives civilization and culture forward, is recognizing when someone's really pushed the boundaries of creative or intellectual expression.
Thank you, John. All right, we only have a couple of minutes left. Okay, let's see, perhaps one more question. Nope. Well, time flies.
So I'd like to, if I can, just show one last image here.
Go ahead.
This is the results of the poll. And the reason I'm interested in showing is it shows what the difference is, the change before and after. So let's see. No, that's not what I want to do. Hold on. So those of you who are on the poll, I think you will see this. Okay, you should see the poll answers, but with differences in the results. And look at the differences. So acting as a Socratic tutor, boom, went way up since seeing an example of it in context. Summarizing research actually went down, which a little surprised me. But the sort of pale version is the original example, and the And the dark version is the example after the presentation. So some minds were changed about certain things, and it's kind of interesting to look at that difference and see results.
Well, thank you very much, John. It was an excellent presentation. Pleasure to have you. And thank you, everybody, for joining us. Sadly, it is that time. So the next webinar in the series will be on the first Thursday in October, and I hope to see you all there. Thank you very much. Have a great day.
Thank you.